Okay. So yeah, let's get started. So basically, the whole idea. I'm going to I'm going to share my screen too as we go. Trying to think how to best talk about this. So I think the main motivation of the optimizer for Qwik, it's easy to understand if you go and you check how Qwik looked like a year ago. So I'm just going to try to show it. So 500 commits in the past, maybe a bit more, 900 commits in the past. This is even more, a little bit more to the past. Okay. Oof. We did a lot of stuff. We did a lot of stuff.
Yeah, I agree.
That was too much. That was too much. Okay, here. So if you see some of the code, I'm going to try to open a to-do app. And this was good still. Wait, this was actually with the optimizer already. Okay, maybe here. So browser, integrations, to-do app. Yeah, here we are. So this is an application, I think UI, and the first thing you see is this, right? That
Yeah,
every component that you have to manually create all these files. And not only that, like the way to declare things was like a nightmare. Like the template of the component is this thing. And it makes sense when you realize that every little piece you need to be able to execute every little piece independently, right?
independently. Yeah, yeah,
So when you start, the Qwik starter has this how to achieve resumability, like just the naive way, let's say. And Qwik went through several refactors before I joined the team to polish some
okay.
aspects, but still pretty much required for you to put things in a different place, call like injector, like all this crap that doesn't really make any sense for the user. Like why I'm doing this, right? So technically, there's the optimizer came from the problem that bundlers rollup, Webpack, all the bundlers you can imagine, they are very good at putting things together, but they don't know how to separate things. So even if you have one file with all the functions perfectly separated, rollup is not going to make different files.
No,
It's not going to do it. Even if you already split it up in different functions in the same file, it doesn't know how to split files. So the idea of the optimizer was like, let's only start with getting these functions already exported and put in a different file. That was ideally the whole idea. Later, we realized that we could even do it with closures. That's what I will talk later. But that was even like, it came a bit later. Another context to understand is that we call it optimizer because you don't need it to run Qwik. So it's still today, if you actually go to, I don't know, let's see one component, like this component of Qwik, and you execute this in the client, like in the browser, without server, it still works like React.
yeah,
Like it will work like React. No transform is needed. GSX, right? GSX, you need to transform it.
yeah,
TypeScript will do that, right? TypeScript, just a TypeScript transfer will be enough. It will work. It will not be resumable because you run the whole thing in the client, so it doesn't make any sense. And you cannot pause it, right? You cannot also do the pause resume thing, but still runs. It will still run the same as React or Vue or Solid or all the other frameworks, basically. Any questions or like something you want to ask me?
No. Right now, it makes a lot of sense because basically, it is basically what the point of seeing what we have now and what we had before sheds a little light on how far we've come, and then seeing the fact that what brought about us having to go through the optimizer method, knowing fully well that okay, we want to abstract some of the things that users were currently doing previously, and then also know that we put the users first before we actually.
Then we. Okay, next point. Next point. Maybe you can take some notes. I don't know if you're writing something or if you want me to, but
I'm writing. It's fine.
Okay. I think that the another point is that we are not replacing rollup, right? We are not replacing Webpack. We are not replacing any of that. What the optimizer does is something that runs before bundling to separate things. And then rollup is very capable for putting things together in whatever order you want. So the whole point of the optimizer is not to bundle things like how it does it. No, the only thing that the optimizer does is let's split the code into the smallest possible units, right? Putting code together is sole problem in front end. Webpack does it beautifully. ESBL,
Yeah.
everyone does actually bundling is that, right? That's almost a definition of bundling, right? Putting things together. So all this work of when a developer sometimes has to optimize an application, they come up with this monolithic thing. And one of the first things is like, how do I split this up? And splitting up is not easy, right? In Qwik it is, because we cannot find the right semantics. This is also why the optimizer for Qwik only works for Qwik, right? It's not like a general purpose thing that can work everywhere. It's not like something we can release it as a rollup, because splitting things, it's not that easy as putting things together. Splitting things means that there's a collaboration between the runtime and the optimizer to come up with something, right? And when you have an Angular app or a React application and you have to split it, you have to go to the code, you have to change things, you might have to refactor things. Maybe suddenly there are new promises, but before you didn't have. So there is a lot of work a human had to do. It cannot be automated. So when we start to, everything makes sense.
Yeah. So basically, we're saying for us to be able to optimize our own, for optimize Qwik, you need to know what you are trying to optimize and the semantics that it takes to optimize what we're trying to optimize, because we want to break it down. So we know what we're trying to break down, and there's currently nothing that does it outside. So we are creating something to break down what we, So
and let's say in the runtime side, there's this QRL thing. Maybe you hear in Qwik. The QRL is kind of the runtime aspect of it, but the optimizer generates this, right? And relies on this runtime to be there, because if otherwise you cannot split it. So that's another thing. The optimizer doesn't have any runtime. The optimizer doesn't execute anything. It just specs that things are there. Basically, that's the thing it does. It's implemented using this project, SWC. So SWC is like a library in Rust for JavaScript, right? But it does a lot of things right now. Like it has minification, all sort of things, right? We use it, and I think if you go to the SWC, there is some plugin system in JavaScript. We don't use any of that. We actually use SWC in Rust. So we import SWC from Rust to Rust. Like everything we do is in Rust, right? It's not like we use the plugin system. We literally use the API that they expose, right, to build all these things. Let's go back to code. Everything lives within the Qwik package. We have a folder, which is the optimizer. And inside the optimizer, there is some JavaScript, which is the glue code. When developers use the optimizer, they use the optimizer through some JavaScript API. But deep down, it's either creating a WebAssembly module or is actually doing a native calls or something, but they interact with some JavaScript glue code. And here is where we have the whole Rust project, which will be this kind of mess because we never really went like a cleanup, like a deep cleanup. But there is literally not many things, I suppose. It seems like a lot, but it has this a function that is transform modules. Okay. Then there is another one which is transform fs, which is the same, but Rust will go to the file system directly. So we have fast pass for that. Like we can, the performance of this is it can do all the processing as possible in Rust. Like we don't have to have communication back and forth with JavaScript all the time. So that's why we have the transform fs. So everything happens in the Rust LAN. If not, we have the transform modules. Transform modules, we even have it in JavaScript interface. So maybe this is actually a bit easier to see what we have. We have different settings, entry strategy, minify, different things. But at the end of the day, what is relevant is that we pass input, right? And the input is really an array of a piece of code and a path, right? That's it. I say this JavaScript file, this content is in this file, right? And I pass all this information in an array, in input, right? An array, I extend type options. And the optimizer will do the job.
I have a question.
Yeah.
So that path, is it a normal string path or is it somehow related to the QRL? Or is it the optimizer that then generates the QRL based on the path that was sent?
You mean this one?
Yes.
Okay, so the path, it's a good question. It's a very good question. So most of the transforms of Svelte, like solid, all these things is one-to-one. It's a transform where you give me some code and I give you some code out. In this kind of transform, you don't need the path. I don't care. You give me like JavaScript, I do some change and I give you JavaScript, right?
Okay.
But in Qwik it's different. Because in Qwik you give me one file and I might give you five.
Fine.
So I can show you in here. Very simple. So we have this piece of code. And it's one file, right?
Yes.
We actually generate all these different files, like 1, 2, 3, 4, 5. So for example, this store plus plus, this is maybe this one, right?
Yeah.
So the transform emits several files. The path is important because if we go back to the original file, let's see. Let me see if I can see it. So a click handler. Right. See if I see a click somewhere. Yeah.
Child.
I'm going to make production. Oh, no, yeah. Okay. Yeah, I have it. Yeah. Yeah. So see that this file is referencing another one, like this file, the template is referencing an onClick. right? And is referenced in another file. So
Yes.
we need to have a path because we will emit the files in a location. Like it's not like physically it's there because it's going to be all in memory, but we need to have a sense of where the files here are to be able to generate the things right in the right place.
The
So
function.
the path is important because we emit one-to-many. That's why it becomes important. One-to-many, and there are references between them. So the optimizer needs to have a sense of the file system. It doesn't really will look into the file system, but it needs to have a sense of where things are. So that
makes sense. You can keep track of, and it's still connected to them and doesn't lose track of them. So that it doesn't lose track of them and it's still connected to them based on the fact that it's trying to build out multiple files from that one file that was sent. Yeah, that makes sense.
Yeah, exactly. This is important. So the thing most important, deep down, like when we start to make the optimizer, we didn't know exactly what was the thing that it needs to do. But the most important thing the optimizer does by far is, I'm going to show you some shots of the optimizer so we can explore what it's doing. This one, I think this one is good. No, I don't think this one is good. Let me see, wait. Entry strategy inline. This is one of the inline ones is irrelevant. Okay. Inline. Okay, this one. So preserve. What is preserve here?
The P.
Yeah, here.
Oh, yeah.
So imagine you have, I've been showing that the optimizer split things. But that's not the most important thing it does. Split things is important. But the other important thing it does is that it gives names to the closures. I'm going to explain this. So imagine we have this piece of code, right? And we have this on click. If you think like, you can think of QRLs, you can think of any crazy term, but when you need to serialize something, you need to serialize when you click this paragraph, you need to execute this
Piece of
function. A function you cannot, you need to serialize a function. How do you serialize a function? You need to, if you have a name, maybe you have already ways. I can actually do something like this, right? Function hello. Imagine I was able to write something. At least now I can say hello. Okay, I can connect the click with a function. Maybe I could serialize something like on click hello, and somehow we will put hello in the global scope, and it works. But most of the times, developers write code like an arrow function like this, right?
Yes.
There is no name to it. How do I serialize this? How do I put this in the HTML? So in the server, if you think about it, when you run the whole application, in the server, you don't want to split things into a million files because in the server, you want to just run it as fast as possible. And that's it.
Yeah.
So when we compile for the server, the optimizer has different modes, and in the server, we do a slightly different transformation. And the slightly different transformation is this. It's the same code as before, the same arrow function here, or in here, the on click, see? The console warning here, but we call it inline QRL. It's inline, the content is here, it's not in a different file, it's all here, but we give it a name. This piece of code is called app component. It's literally app
Paragraph and click.
component. Yeah, no, let me see here.
Paragraph.
App component CMP paragraph on click, right? That's literally what it says. App component. This is for development, right? In production, it's going to be something like this. The hash at the end, still the same. But that's key, because now when we run the server, we don't know about anything about where this code will live in the client. We have no idea, but we know the name. At least that's the same thing. And in the client build, it's going to have the same name.
Yes.
Okay. This is the only thing important. App component, this thing over here. Okay. You might imagine that just by having this, if I give you, here's the click. Is it useful for you? Like the browser
No.
I cannot do anything with this, right? What's the other missing part you need? We need a map, a map. We need a map that tells me this thing lives in HTTP docs Qwik build.com build symbols. And now I can, right? Because and now whenever I see this symbol, I know that if I have this sort of like a map, right? And in the map, I have a map that tells me this symbol lives in this file. Now I can, right? Now I can resolve it and download it. And that's exactly what happens when you build a Qwik application with Qwik. So I'm going to go to this application. I'm going to do npm run build or preview. I think preview is good enough. So notice that the first thing that happened is that it builds the client and then it also runs the server, the preview server. Okay, in this case, so it does. Oops, I need to. I'm debugging here. Okay. Build. It will do the client, the preview, both things. Okay. So you will get two folders, which is this folder, which will be the server, the browser, all the browser files, the static files, and then the server. And the server file will be just this file, which you execute, and it's like a node server. That makes sense?
Yeah, that makes sense.
The node, when you run the server, I'm going to run it here and open the page. Let's see if there is any click or something. Yeah, there is some click somewhere. Yeah, like this click. So notice this is important. See that here's the symbol that we mentioned before.
Yeah.
But the server, somehow, the server also knew that this symbol lives in this. This file is not a server file, right? Notice that the server only needs one file.
One file, yes.
This server like is Q00E, right? Q00E. This point is going to be here somewhere. Yeah, Q00E. See that? In the browser build.
Yeah, browser build, yeah.
So they need somehow the server needs to have this knowledge. And that's what we have the Q manifest. That's the other missing piece in the whole thing. The manifest has this part of the code, which is the mapping. Let's see if I find it. Symbols. And says, for example, I'm going to open the server, right? So I'm going to open the server file, which is here. and maybe we find some symbol somewhere. So let me see, yeah, this symbol, for example, is in the code somewhere, S0Q2.
Okay. Yeah.
Right?
Yeah.
This doesn't mean anything, but the server has the manifest, right? And it goes to the manifest, to this file that was from the client build, and it's, oh, here it is. It's in this file, which is, and then with that information, it can serialize something that later will work, right? That's giving names to the pieces of code and putting in a different place. But especially the giving the names is the most fundamental thing that the optimizer does. Give names to closures. Super important. That's
just one quick question. So
yeah.
basically what it does is the path and then the name that was given to it by the serializer, and then uses the manifest to find it, and then that's how it is able to know when we have gone from the server, when the request has been made from the server, right?
Yes. Yes. It's the server is not using the manifest to load the file because it has everything already.
Yeah, it has. Yeah.
It uses it to, when it generates the HTML, like all the HTML, if it only be able to know to put that in the browser, it's like, where do I find this for, right? In this case, it could be, but it could be even like, imagine, it could be something like google.com build something, right? It could be any place.
Anything, yeah.
And if I change that here, right, I put Google, it's not going to be that, but if it was in a different place, file, then whenever the same server, exactly the same server, but now by a change in the manifest, whenever it finds this symbol, when it serializes, it knows, okay, I need to tell the browser that this file, to find it, is in this file. So that's the only thing that, or the most important thing that it does. I think overall, that's the
how it, that's basically what it does, and how it does it. It makes, now to me it because basically, obviously at first it just looked like, how is it magically creating names? And because I know I have seen the first video of just a quick rundown, and I saw the QRLs in action and how the QRLs work. But then I the only one question I have is, when the optimizer is generating names, when it gets to how unique are the names that it creates? How unique are those particular names, the identifiers for each one?
How can we make symbols that are unique? You mean like
like the unique, So
very good question.
Because I know it would get to a very, because I think based on, if you show me an example, we have how many combinations? I think it's about maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 characters long. A particular one, the one after the the one after.
So this is interesting. So imagine, okay, these hashes are not a hash of the content. I don't know if you, so these hashes are not a hash of the content of the symbol. So for example, let me go here and I'm going to, for example, this file, right? See that it's store count plus, and the symbol is OL02, right? If I go to the code and now I change it to plus 10, okay, I'm going to go here. See that you put plus 10 here, right? But still the same name.
Yes.
Remember the path we passed before? That's important here.
Okay.
The hash is a combination of the path that was sent before, the code and the path, and the location inside this file. So, for example, for this on click, how do we differentiate this on click that we see here from, let's say, another one that I have here, right? Imagine I do another one in this place. We have also a path inside the file, and the path inside the file is default, right? So imagine this is app tsx, right? So we have app tsx here, app tsx plus default plus component plus div, right?
Div, yeah.
Plus div plus
Button,
button plus,
yeah.
and if we go here and do hash of everything, it will make. But
Yeah.
we inject one more to prevent issues. So we also look at your application. So in the package JSON, the name of the application.
Okay.
So now is my Qwik basic starter plus app plus tsx. So even if you have the same, everything the same, but is a different dependency, let's say you have Ionic or like Material UI, that package will have a different package JSON. So it will generate a different hash. It will not be a collision there. And with this amount of characters, the probability of having a collision is you will have to have a billion components to almost have a chance of 1% to have a collision. And if this happens, we will add one more number. If that happens, we will add, okay, let's put 8. So it's not gonna happen.
I understand. Yeah, I mean, but since it makes more sense because what are the odds of even having the same file with the default there? From that point, at least, it's even really hard to get into that that formation. That makes sense.
Yeah.
Yeah. Very beautiful.
Yes, it's
Yeah.
cool.
Yeah.
I don't know. Yeah, one more question, something like about the RAS code.
So
Yeah, tell me.
yeah, exactly. So yeah, my question then would be: so now we have the high level. We know what we're trying to achieve with the optimizer, what is being passed into the optimizer, and what is coming out. And then we know that basically it's powered by the SWC from Rust. But then from a functional perspective of what the parts that are actually inside the optimizer that does each part of this beautiful
Okay. Well, okay, let's see. So let me go close this. Okay, packages, Qwik, source, optimizer, core, source. Okay, this is, I don't actually like this thing that adds anyways. So we have the transform FS, transform modules, the 2 we talk about. Both of them call the transform code, right? They only transform code. But it has an extra thing. So you usually transform code and that's it, one to one, all right. But transform code actually can give you actually multiple files. That's one of the things. Transform code can give you multiple outputs, okay, as we talk about. So let's go to transform code. The transform code, I'm just going to try to go here. So the very first thing, okay, let me see if I can change, let me see, Rust analyzer automatically. There's one feature, I enable it and I actually don't like it much. Additional text edit. By the way, we are going to run out of time soon, I think.
Yeah.
So 4 minutes.
Yeah.
Okay, whatever. I will change it later. So it's just too noisy. It's just too noisy. But we get the code, and the first thing we do, obviously, is to parse it, right? We get the AST. For that, nothing fancy. It's a bit boilerplate, but we read the lecture and we just parse it and we get AST. So nothing fancy at this point. We get a module, and then based on the module, based on in Rust, you have this match, which is like a switch, but with superpowers. Basically, as okay, the module loaded correctly, we match it and we just process. There is no exceptions. Like when you get the module, is actually like a result of a module. So maybe even error. So we just match it. That is actually it resolves to an actual module. And then this is just magic with extensions. But at the end, this is the part of code where we start to process, right? And the first thing we do is to remove types. So you see here, if it's TypeScript and we enable the transpilation, we will remove the types. Is not type checking. It's literally a transform that SWC includes, which allows me to remove the types from the AST. Because we don't, again, if you enable it, if you say transform TS, like the optimizer of Qwik can actually process TypeScript and emit TypeScript. That's super cool because we actually can do transformation without losing the types.
Yeah.
But if you enable it, we will remove the types. That's the first thing we do before anything else. Okay. The second thing we do before anything else, this is actually the order of these things is relevant. Before splitting things up, before moving things around, we remove or we transpile GSX. So there is a transformation, which is the React transformation. We apply it here. Again, think that it's the same AST, is super efficient. Like it's not like doing like multiple, it's all doing the same transformations under the same AST. Source map are going to work, right? All these things are going to just work because it's part of the same pipeline. Okay. When we finish everything, there is one step that's also done by SWC, which is a resolution of identifiers. A resolution of identifiers is very useful for latent processing because it resolves the differences between, I'm going to post, and we have 1 minute left, but in mind you have something like this, const a 12, right? And now you open a block and say if something, and then you say const a equal that,
Yeah.
console log a, right? So when you are parsing this, you will get identifier in the AST, you will say identifier A. You don't know which one it is. What the resolution does is basically it will call this 2. So now all the identifiers are unique, which is very interesting property because now it's things become easier. Like that, you don't have to think that, oh, what if there's a conflict of, no, because you resolved it before. So that's what this line is. And it does it after we transform types and everything else. So at that point, we can start to do like analysis because, yeah.
Okay.
We have less than a minute. It's going to crash soon, but we can join another time.
Okay.
Okay, so another thing we do here is that we collect the globals. So this is not a transformation. It's using the same AST and we collect the globals. That means this module, what kind of imports? Don't pay to Zoom. Okay, so I don't know where I was. Oh no, what is this?
We're talking, global collect. Yeah, that's fair.
What is this stuff? It's showing me this thing here. Okay, never mind. Let's put it here. Okay. So the global collect, if we check it out, it's in SWC, you have visitors and visitors that can do mutations to the AST and folders, folding. So a visitor is very fast because a visitor just will walk through the AST without making any modification or anything. You can just walk through it, no modification. So for to collect information, we use a visitor in SWC. And basically, the way to declare this is that I implement the trait in Rust for visit for the global collector. And then it has these very nice things. I call it visit and what I want to visit. So visit import declaration. It will automatically get me this. So imagine I wanted to visit objects that happen in the thing. I will do this. I usually do this. This is my workflow. I copy the line. So literally I copy that. Then I go here and say object lead. I don't even know what is that. Then it's going to complain, right? Because I need to call this function the same. I have to call, so it says object lead, I have to call visit object lead. And it will be called. I don't have to do anything else. Here I implemented my logic, right? As you can imagine, to collect all the visitors, I visit the module items, so the lines, the global items, the import declaration, the name export, the export declarations, the export default declarations, different AST nodes that I have to visit, and I collect it. So I put it in a sort of like an array here, like a hash map that later I can use. So this is one of the things we do before getting forward. So when we get the collect, here's where 90% of the magic happens, is the Qwik transform. So in the same way that we have resolve, see that resolve is a visitor that does mutations.
Yeah.
The one that I told you that changes to 8.1 to 8.2. The React is a fold. What is a fold? What in SWC, a fold is like a visitor, but it copies it. So it's like a bit less efficient than a visit mutable. So a visit mutable is very efficient because it can update in place. It doesn't need to copy the AST.
Yeah.
Folding copies the AST. Why is a folder? Is a folding because it's easier to do a mutable visitor. In Rust is tricky because you know how Rust is like very strict. There's a lot of things that become tricky because even if it's a mutation, it will be safe. So it puts you like a lot of restrictions still. The folding transformations are like the easy to do, right? So that's why we also have a folding mutation. The whole transform is a fold transform.
Fold on it, yeah.
And I create here is the Qwik transform. And the Qwik transform needs a lot of information. It needs the entry strategy. If we explicit extensions, it gets also the global collect. It gets also information from before.
Yeah.
The scope. So I told you that we take advantage of the package.json name. That's the scope. Yes. So we are able to generate the hashes correctly based on that. All the information, right? The inline mode is here, everything. Yeah. We run it. That's it. Boom, done. So if it's, we have a config for minify. So after doing all this stuff, we minify, and then we have these two things. So you remember that the resolver did this a transform to true, like the hygiene and fixer, and that's it, because you don't want to be when we actually generate the JavaScript, we don't want to be like fucked up, so the fixer puts it back now. So it looks good, like it looks like JavaScript. So that's the very end thing we do. We haven't finished. So Notice, so after doing this stuff, in most of the times, in most of the frameworks, most of the transformations in the world, we are done. We transform, fixed, done. But we have to do more things. So notice that in the Qwik transform now, we get the hooks. We have a state. We actually have, this is the code of the transformation. But now you actually have to emit more files. So after transforming it, the transform itself has a state internally, and the state will be, now this is for this file. So basically we loop through it to all the hooks, which has its own state, and we create a new module. And this module takes all sorts of information, like the expression, the path, the name, the local identifiers, the scope identifiers, all the information that it needs to serialize. And guess what? We do also the hygiene and the fixture. But now for every particular one, notice that we don't have to do the TypeScript anymore. Like the TypeScript was done at the very first level.
Yeah, at the beginning.
At the beginning, so it's being used, but the hygiene is doing at the last level in every step. So this one that we did here only applies to the code that remained in the main module. But you know how Qwik is going to put things in many different places. It's not going to be much, actually. This is going to be little. Like most of the code will live in this for loop, right?
Oh, okay.
Of all the parts. And at the end of the day, we put the module information, which is in this array of modules, and we send with the code, the source map, we save this entry point, the path, the hash, informations about the hook, which is useful for debugging. And this is sent at the beginning. We keep collecting to this array, like push, and we send it to JavaScript. And that's the build. That's everything that it did, right? We emit source code, which will transform AST to a string, right? Because you have to take all the AST and actually code generate JavaScript. And then there is like a lot of tricks with paths. Like path is tricky, but at the end of the day, we just collect like an array of modules, and this array of modules is the response of the transform, basically. The whole thing I show here, the Qwik transform, okay, that's huge. Okay, so it's, but that's everything. Really, the Qwik transform is what it transforms the things, right? It's what really goes through the AST and is the what defines Qwik. Like everything else is like preparing things and like putting in the right format, but transform in these files where all the logic lives, right? And I'm not going to go through all of it, but I'm going to show how it does, for example, how it does this, how it finds something like component dollar, right? How it finds a component dollar and breaks it. Because when you have a component dollar, you will have something like this, right? You will have component dollar and an arrow function, but it needs to transform this. So two parts. It needs to find identifier that is component dollar. There's going to be an identifier that is component dollar, but we are even more advanced than that. We only get identifiers, component dollar, that are imported. So if you import component dollar and you do as this, like you rename it and you do this, it still works.
Yeah.
Because we don't trust the name of the identifier. That's what I'm going to show here. In all internal state, there is Yeah. Wait. No. Marked functions. Exactly. Mark function, what we call the mark function. The mark function is the function that are marked with the dollar, right? So in this list, we create a hash map, right? Mark functions. And then look what we do here. We do a for loop from all the imports, right? And then we insert it to the map, right? And also all the exports. And we create this map. And then this map, guess what? When we do a fold call expression, which is the fold call expression is literally Kali and that, like in JavaScript, like a calling expression, is where we check and to, is it here? Let me see. Yeah, in this, oops, wait, I broke it a bit. Yeah, here, this line. It's like, we do a get to the map, to the identifier, and say, is this identifier in the map of the mark functions? Right? In this point, I don't look at the dollar. I just is the one I'm looking for, right? And at this point, what I do is that what I do at this point is that all the code at the end of the day, it goes to something called create QRL, create synthetic QRL, which is a function that will do the whole analysis about the variables that is disclosing around. Yeah, the local identifiers here, all the stuff. It was a bunch of logic, and then it gets the scope events. So the scope events are like the ones I need to include, like the ones that I need to include. And basically, at some point, it collects all this information in a hook data, and then based on different conditions, I either render an inline mode or in a different file. And when it's in a different file, as you can imagine, what I do is that instead of rendering anything, what I put is all the information in this array. And this array is what you saw in the other function that later, after doing the transformation, I walk it.
Oh yeah, the loop that we saw.
Right. So what I do is if I find the component dollar, I put something else, and then I put the actual content in this array, and after the transformation, I will go through this loop and put it in files and stuff, right?
Okay.
So
yeah.
It looks complicated. It is. At the same time,
it makes a lot of sense based on the way you're explaining it function by function to say we are basically for everything we're doing, we're catering for different steps that might come up based on how developers might write the code. So that makes a lot of sense.
And the test, for example, how we test this, right? So there are no unit tests, 0 unit tests. I'm not 0, very little unit tests. Because what is interesting right now is not to test the implementation, but the output. Like an optimizer compiler, obviously the unit test will help you debug better at some point, but the fundamental thing is that you got this input, it needs to give you this output. I don't care how. I don't care how you do it. I don't care about the detail of that. I just make sure that it does in this specific way. So we have an amazing system, because imagine I want to write a new test. Imagine you come up with some, for example, there were a test where, let me see, assertion. See that? This JavaScript thing? We didn't support that at some point, no? The way to add a test for this is that I literally copy one of these functions, of these tests in Rust. I copy paste the JavaScript code that is the input. I simulate in a path or something. And I configure whatever I want to do. So in this case, by default, transpile false, everything is false by default. So I can change the default, and I put this, and that's it. I don't have to tell how it is, right? That's it.
Yeah.
Imagine I go here and I broke the transpilation. So I put this false. So imagine in the code I break it for this test, right? And now it's not doing the transpilation. So when I do the test, this is what is going to happen. Cargo test. Okay, I need to undo.
It changes.
I need to undo some stuff. So I'm going to undo this, undo that, and do that too. Okay, so I run the test. Okay, something happened. What happened? In this test, there are no types. So the only thing that changed was this, that the extension came from javascript.txt. So now the test failed. If I want to approve this, so I'm not going to approve this change. So I will detect it.
Yeah.
But imagine I actually want to make a change that I want to approve. So I want to put back this, and I want to say, I actually want to add a comment here. So it's fine in the input. So I rerun the test. It's going to fail. And I do cargo, yeah. Let's see what happens. So the source map change, makes sense. And then this is the input that changed, but the output changed as well, right?
Yeah.
If I want to approve it, I do this. It's cool. So I do cargo insta, which is like a testing thing, and I do review. Let's see. Review. And then I have accept, reject, or skip. So I'm looking at it, and yeah, this change is good. So I accept it, and that's it. And now if I do cargo test, all passes, right?
Yeah.
Super fast, by the way. It's running like this 100 tests, like in Rust, like in nothing. Like it's
amazing how fast.
Yeah. And what is the other thing? Yeah, the same. Like today, actually, I make some improvement to the optimizer to fix one issue. Not the issue, to have a new feature. I actually recorded a loom, so I can send you the loom if you want to check it out.
Yeah. Is it related to the other update Shai gave about the 14 times increase in speed from you, the guy from Vue? Or is this like a different? Yeah, because I saw that one too, and that was really exciting about. Yeah.
Oh, so that didn't involve any optimizer change.
Okay.
But so the whole thing with Vue was that he posted something like resumability can be slow or something like that. That was like, resumability can be slower than hydration. And I'm like, it's not, no way. If you do resumability good, it's cheap. Like it's nothing happen. Like it's literally by definition, there's nothing to work on. So when the example he made was an application with like 1,000 components or like more, like almost 500,000 elements in the DOM. And the problem we had is that, and every one of those have a click, and every one of those have a state. So it was like massive application. The problem we had before is that every time you click the first time, we have to resume. And the whole resuming thing was going through all state and
millions.
Everything. Yeah. But that was the naive implementation. Now the new implementation is I just need the state for that click, right? So now instead of taking 1 second, it takes 2 milliseconds. It doesn't matter. And Vue takes like still half a second. And I'm going to say that half a second is good because they have it's a test that doesn't stress hydration, right? Because there's only one component in their test. But if you actually check it with an application with, fuck them it, with multiple components and doing processing, then it will get worse. So that was the thing, but that was runtime. That was only runtime.
Okay.
Yeah.
And yeah, this is really great stuff. I'm really glad I could actually get to see this.
And
Really
I'm
excited.
going to say, if you want to learn Rust, I don't know, this obviously this is getting a bit already like complicated and it's not being cleaned up and there is not like much to do. Like the optimizer, when it works, it works. There is some PR open for something is complicated. To be honest, like it's complicated, not Rust, but the project itself, because yeah, it's just a bit complicated. But Rust itself, I learned Rust, the first time I used Rust was to make this. So that's why I'm also like not too bragging about it, because probably some Rust developer look at it and it's like, this is shit. So that's why I'm not like very showing it around. But
yeah,
I will say that Rust is this language where at the beginning you don't know the rules, right? And you at all the time hitting like some blocker, right? All the time. At the same time, the error message are so good that it gets you on block most of the time, like all the time can find it. When you pass this, like initial like friction, it's amazing. Like you write code and you are very safe that it's fast, because it doesn't matter the abstraction. You don't have to think about how to. It will be optimized, and you know that it works. If it compiles, it works. And at some point you become super productive, actually, because when you don't hit the walls, then the optimizer makes sure that everything else works correctly and there is no memory leaks, there is nothing, everything is perfect. And it's very nice. I have to say that it's very cool. I have fun with it.
Yeah, I would definitely make sure to take a look at it, because I would want to go more into. Obviously, basically, I would do the diagrams and everything I will review, but personally, I also want to go more deep dive into how the whole transform works and everything. So yeah, I'm definitely.
Now that you have it, if you want to check it out and later async, you are me. This piece of code, what is this doing? Even I'm going to tell you, like, if you want to go to the code and you just want to refactor it, like to change things, and the test pass, like you do cargo test and it passes, let's merge it. I don't have any problem. That's why I also like confident. Like you change it, the test is passing, all good. And the tooling is very good. I think even is better than JavaScript. I think there is always in JavaScript, there is like yarn, npm, you go here, you do cargo build, and it's very likely it will work reliably. So in a way, it's actually easier to start with this. Cargo test, you do cargo test. Cargo test is what I do all the time. A cargo test, it runs it every time. And then make sure you have Rust Analyzer as a plugin in VS Code. Otherwise, it's just impossible. Rust Analyzer, the plugin, install in VS Code. Very important.
Okay, sure.
Yeah, that's it.
Yeah. Thank you. Wow. So this was really, very insightful. I'm really happy about this.
Yeah.
I'm really happy. I'm really happy. I'm really happy. I can't wait to see what it looks like and then share with you.
Yeah. What do you want to do with this? It will be nice to, maybe we can have this video posted somewhere or like in your channel. I don't really matter.
Yeah, sure thing. Anyone, I could post it on YouTube anyway, or you could post it. But I think I would also need a copy anyways, because I think we could also, this would really go very well with the other video from the previous session we had, where we had a lot of people in it, where you were talking about, the high level.
Yeah.
With that.
So maybe we can do that. Maybe I can upload it YouTube. I can clean it up with this script. I send you the video,
okay.
and also helpful for you to finish the blog post.
Yes. Thank you very much, man. I really appreciate this.
Yeah, no, it was.
I know it took time. Thank you. Okay.
All right, man. See you around. We'll stop.
Have a good day. See you around. Bye.